Thank you.
Can you hear me? Oh, yes. Oh, my God. It's really loud. So, hi, everybody, and thank you for coming today in our presentation. Jacques and I will talk to you through our journey of how to develop and implement the Monitor Data Foundation, the benefits that we have, but also some challenges and some next steps. But first, we need to test your eyes. As you can see here, can you read fast? No. In a most serious note, what we try to say here is that whatever we present today is not intended to drive any financial investments or we release any financial information. So we talk about digitalization many times nowadays, but for me digitalization is an opportunity, as a transformational opportunity for our industry and of course for Shell. Digitalization is not new. We capture data from sensors, monitoring hundreds of thousands of pieces of equipment. What we try today to do is to analyze the data more clever, make sense for real-time data in real time, and try to understand how we can, based on the data inside, create value to the business. From digitalization perspective and operation, the strategy that we have in Shell is what we call the asset of the future. That's what we want to do. And the asset of the future is an asset that it's fully digital, agile, optimized, that enabling to have real-time, flawless operations. So from one side, we have, the beautiful, vision to achieve. But from the other hand, we have a big challenge because we need to help the operations to achieve that vision, but without actually interrupt their everyday operations. So what we try to do with Jacques is to provide the end users in the operations, in real-time operations, data, real-time data, trusted data, respect from where they're coming from the source of the data, the technologies that we use, to help them to compute their models, to analyze and find faster in the operations, the inside operations as they call it, and to do that in a consistent way. And what I described here is what we call data fabric. So our model, our data platform for the Monitoring Data Foundation is based on the data fabric as a concept, because the data fabric is a concept.
Went dark.
Dark. Okay.
There we go.
Dark ages. My name is Maria Papastathi. I have more than 26 years business experience in operations, IT, new energies, and acquisitions and divestments. And in the last 6 years, I'm working as a guided, I must say, person to senior teams, executive teams, in investments for programs that data, technology, and culture is a key change drivers to what we call improve business gap to potential. In other words, we try to generate more money and create value, to the business. And in order to do that, I had the pleasure to work for many teams, central teams, in the innovation teams, in the analytics team, from the central office, but also from the assets, and also a lot of subject matter experts like my co-presenter, Jacques, for the Monitor Data Foundation.
Thank you,
Over
Maria.
to you, Jacques.
So, welcome again, everybody. I'm Jacques Vosloo, and I work in a team of product owners who works with DevOps teams to deliver technology supporting proactive technical monitoring. Now, whilst you can see on the slide here our asset management system definition of monitoring, for those that's maybe not so informed, I think a good analogy is if you look at an automobile, sometimes you get sort of a traffic light dashboard where you've got low tire pressure, you need to get your engine checked, or you get an email from a manufacturer. That's sort of what proactive technical monitoring is like. Now, I decided to include this slide. The original research was actually from Gartner. So Maria talked about data fabric. And we got a slide like this. And I must say in the beginning it was rather hard to read. But the more we started researching the concept, we started to gain a deeper understanding of what data fabric is and what it will actually allow us to accomplish in the future. Now, Maria mentioned the asset of the future. This is an autonomous plant. And we're doing it for various reasons. It's about limiting our emissions. It's about helping us to achieve goal zero from a safety perspective. It's also there to help us be more productive and ultimately add more value to the business and our shareholders. The autonomous plant, or asset of the future, refers to a state where things are being done automatically. You don't have a lot of humans doing things. It's AI doing most of the work. Now, that's pretty far away for us. We're nowhere near to actually getting there. But a core concept to get implemented is data fabric. And if you look at this diagram, if you sort of look there in the middle, you see these blue dotted lines. That is what that's the role of the Monitoring Data Foundation. We're trying to establish lineage with enterprise master metadata and activating it in bespoke views that all the different monitoring technologies can make use of to aid in rapid deployment of visualization and analytics. And that, yeah, so, and it goes between the, the data providers that you see at the bottom and the data presenters at the top. And, at the top, you've got structured tools that, that different personas are using. You've got discipline engineers looking at, specialized monitoring tools for rotating equipment, static equipment. You've got data scientists who's trying to use data sets to predict things that's going to happen in the next couple of weeks. You've got people who just want to investigate a particular event that we've detected and kind of navigate through the data. And that's why we have data fabric as a concept. Now, this is the business end of the view. This is really what monitoring is about. And you can see on the right-hand side of the slide what the different work process requirements are. And it starts with creating your technical monitoring plan, which is nothing but a set of activities, processes and equipment that you want to monitor, and identifiers in a real-time data lake that feeds into that monitoring. The execution is done across the analytics continuum. So currently we're doing descriptive, diagnostic, and predictive analytics. And then, you've got a workflow to deal with, events that we've detected, and, you figure it out and you create maintenance execution work orders, or you get vendors in to help us analyze the problem. That's essentially what PTM is all about. There's 4 key forces at play here. We want to be able to integrate the data coming out of our monitoring technologies with the rest of the enterprise. This could help us achieve a condition-based maintenance strategy, for example. But in doing that, we need to ingest master data, master metadata that comes from master data systems. There's also varying view requirements from the technologies or the tools that you see on the right-hand side. A first principle modeling engine works differently to an analytics tool where you just want to pick up, references of data and trend it out and see if you can find patterns in the data. On the left-hand side, you've got people doing the monitoring planning. So these people don't want to be going and looking for identifiers in a massive data lake. They just want to be able to find this stuff, compile their plan, and have a cohesive view end-to-end. And that's why we've created this blue block in the middle called the Monitoring Data Foundation. We are ingesting or ETLing master data from those systems into our database, but we're also allowing for self-service addition in the same fabric to that database that then later on gets synced up with the master data systems. And then using some fancy coding through my DevOps team, we can shape the hierarchy that you get from a master data system into bespoke views that you need to feed into a first principle engine model, ad hoc analytics tools, workflow engines. These all use different views on your metadata. And that's what we do in the database itself, and we expose that through a GraphQL API. That allows some market tools to pick it up through an ETL sort of mechanism, or applications that can just pick up the data on the fly. And GraphQL is quite capable in that sort of in its API, because you can really limit the data set to what you really need for your visualization use case. Right, so what have we done so far? We've been able to build the self-service portal. We've been able to bring all of our monitoring technologies together. So there's a sense of community around data identification. So instead of reinventing or rediscovering data all the time, we're doing it once and we're reusing it all the time. So when we deploy different monitoring technologies to the same asset, it's an incremental approach rather than, dear asset user, can you please tell me where to find these and these and these instrument data in the field? So that's great. We've proven that using master metadata that we can integrate with the rest of the enterprise, but as well as a digital twin, which is massive for our PTM Global Centers, for example, that's based in Bangalore and New Orleans. And the last thing is on data quality. So all of the instrument data that we use in our PTM process is cataloged within the Monitoring Data Foundation, which is an ideal place where you can run your data quality rules, right? And that's exactly what we're doing, and that's what we're feeding our data quality assurance teams to remediate those data issues. What we're working on at the moment is to be able to tell engineers, in context of the monitoring activities that they're responsible to do, these are the data quality problems that's preventing you from maybe having, doing the surveillance properly and the blind spots that's in the process. Apart from being able to replicate technology faster, et cetera, we've also been able to rationalize legacy technologies that actually, surprisingly, amounted to millions of dollars. So, I think the message here is if you work smart with your data, you actually find opportunities to rationalize technology, position things for what they really are meant to do, limit the overlap, and ultimately for your technology customers, it's just clearer what the different technologies are meant to do. Yeah, and I think, I think the point around the data, of course, we're consuming more data. We've got a lot of new energy sites coming up as well, but the costs have decreased. I think the increase in data usage is a result of the Monitoring Data Foundation, but the decrease in cost is really us leveraging cloud and those technologies to expose the data. And what we're doing is the MDF shows a relationship of data, but through an API economy, the different technologies actually query the data from our data historians or data lakes. Maybe over to you, Maria, if you wanted to say a couple of things.
Yeah, for the challenges, thank you very much. Yes, I know. How many of you recognize those challenges? Because in different programs that I got involved, the challenges come over and over and over again. And if you see the challenges have nothing to do with the technology is there to support, to sort a particular, to execute a process, et cetera, et cetera. It's about the people, it's about how they behave, it's about the change that they have to go through and finally realize what it is for them. And unless you go through that process of change and helping people to realize what it is for them, answer the questions, nothing that you will do will sustain. You can implement it for a while, but they will never have, the value at the end. So if what we took out for this program, but any program that I am, I'm getting involved, is to work on the business case. Work, with the people, understand what it is for them, and also focus in a very small area. Show them immediately how it can help them, the solution that you put in place, and then try to scale it up. If we're going all the way around, what we tried before is usually a failure. So focus on the people in the business, case, listen, to them, and try to do something that is very, very small, answering their issues, the challenges that they have.
Yeah. Yeah, I think, key takeaways. I think it's proactive technical monitoring is a highly connected use case, work process. It's got a lot of inputs from, neighboring work processes about our subsurface and surface organization. There's also inputs from the way our discipline engineers recommend to take action when things go wrong with our machinery. a so-called reliability-centered maintenance work process. But then the outputs of our monitoring is also relatable to maintenance execution, or how we go about mitigating our threats and opportunities in production operations. And we've barely scratched the surface here, right? We've only really looked after the data silos that we have for proactive technical monitoring. Imagine what we will be capable of doing, bringing all of these different work processes together. And that's basically where we would like to go next. And there's obviously a lot more players inside Shell that will be a part of that journey. But that's where we would like to go next. In terms of what's next, it's, we've learned a lot whilst actually being here at the Data Innovation Summit. And graphing, the data cataloging and all of that sort of stuff, all the good practices that you do to eventually reach a sort of a data mesh, I think that's essentially where we would like to go to.
Absolutely.
It's about creating an autonomous system where humans as well as machines can discover data. And we believe that data graphing or knowledge graphing technology has a role to play there. We believe having an environment where people can play with their data sets and the whole data mart sort of concept is really going to play an important role to allow for innovation in this space. Help not just a couple of data engineers or scientists define the data that they need to do things, but help the whole company contribute to it, even contractors that work in a particular knowledge area. So that's essentially where we would like to go. And that's going to help us get to the next level in the analytics continuum, which is the prescriptive analytics. Essentially where it's not up to a human to decide what to do next, but based on history, based on input work processes, based on data from the field, recommendations can be made to the engineer and take action from there. That's really going to simplify the overall surveillance process and help us turn around these things a lot faster through our PTM global centers. And that's it.
That's it.